So write the quotient in standard form. So standard form, remember, is a plus bi. Yes? Okay, so that is not a plus bi. I've got an imaginary number in the denominator. Can't have it there. So I need to multiply by its what? What's that word?
1 minus 2.
Would be 1 plus 2i? What's that word?
Conjugate.
The conjugate. And do the numerator and denominator, right?
Wait, is it a conjugate? Oh, I don't. Nope, no.
Okay. So I got to FOIL it out. Oh, so I get 6 plus 12i minus 7i minus 14. I squared. Okay, and on the bottom, I always should get 1 minus 4i squared. Because what happens to the middle two terms? They zero out, right? And that's the whole point of the conjugate. So what's this I squared do? Make the 14 what? Positive. Didn't know I was on my eraser. So it makes it positive. Okay, so I've 6 plus 14 is 20. And then 12 minus 7 is 5. So I need standard form, so it's going to be separated, right? So now I just need my denominator. So I squared makes this 4a positive, so I get 5. Please tell me I cannot leave it like that. What's wrong with that? Reduce. So you get 4 plus I. Well, you can put a 1 there, but do you need a 1 there? No. So standard form is a plus bi, and I will tell you I expect it, even if I don't tell you to write it like that, that is what I expect you to write it as. Questions? Oh, I'm sorry. Were you done, Alex?
No.
Okay. Sorry. Okay. Okay, so perform the operation. So I need to do what? What's it tell me to do? Add. And in order to add fractions, I have to have what? Common denominators. Now, my two denominators here happen to be what of each other? What are they? They conjugates of each other. They happen to be that. But are they always going to be that? No. And I will tell you, I look at them and I'm like, if they're conjugates, I'm like, woo, party. If not, I work this problem exactly like we did the other one and got a real number in the bottom. And then I work this and get a real number in the bottom. Then I get common denominators. Does that make sense what I'm saying? I think I have another one. Yes. So we'll do this one because they happen to be conjugates. We'll take the advantage of that. Okay, so the common denominator is going to be essentially these multiplied by each other, correct?
Yeah.
Yes. So on the left, I have to multiply by 2 minus I. And on the right, I have to multiply by 2. And in the denominator, I'm going to get 4 minus I squared. Multiplying these two together. So what do I get on the left in the numerator? 4i minus 2i squared. And if this was a negative, I'd put a negative 5, right? But it's not. So what do I get on the right? So plus 10 plus 5i. No one following what's going on. Just getting common denominators, right? Okay. So I like to do the denominator first. My personal preference. So negative I squared turns into plus 1. Right? Because it was negative 1. So my denominator is... Am I going too fast? Okay, so what's my real part going to be? What's this number right here going to be?
It's 12.
Oh.
It's 12. Why, Alex?
Because negative 2i squared turns into positive 2.
The I squared makes that a positive 2, so then it's 12. And what's my imaginary part?
9i.
So plus 9, and remember the I goes out to the side. Can I reduce? No. So that's perfect, right? If they are conjugates of each other. If they're not conjugates of each other, you can do the same thing, but are you going to get a real number in your denominator right away? No. Then you'll have to go back and multiply by the conjugate of the denominator that you get. So what I was trying to explain that I'd like to do is I like to do the conjugates first, personally, because I like to get common denominators with real numbers. Some people would argue it's more steps, and it is. It's one more step, but it's just something that I like to do. So you guys can tell me which you would rather do. Would you rather get, simplify... I touched it. Sorry. Simplify this by what I mean by multiplying by 4 plus I and multiplying by I and then finding common denominators, or would you just like to multiply this by 4 minus I
No.
and this one by I?
I like doing it that way better.
Well,
Makes
you know
more
what?
sense to me.
We could do both. We could do both and you can decide which one you like.
I want to do it first.
Okay, so we'll do both. I got this one written. We'll do this one first. Okay, so this one is just getting common denominators by doing the basic not think about multiply by each other, correct? Okay, so my denominator then would be 4i minus I squared. Okay, so then my numerator, please don't come in the middle of class again.
I'm sorry.
Okay, so I have to FOIL the left. So, what do I get? 4 plus 4i minus I squared. And I always circle this because I forget about it. So that'd be negative 3i. Okay. So you want to simplify the numerator or denominator first? What? Denominator. Okay, so the negative I squared would be plus 1. So my denominator would just be 4i plus 1. And the numerator, I like to do real first. This would be plus 1, right? So it looks like 5.
Yeah.
And then I have 4 minus 4, so just 5.
4 minus 4.
Well, because I have negative I and negative 3 is negative 4 minus 4. Four minus 1 minus 3.
Okay. That's just one.
No, 4 minus 1 is 3.
4 minus 1 is 3, minus 3 is 0.
Yeah.
Yes, so that's, I don't put anything there. It'd be plus 0i, but you're not going to write plus 0i.
Okay.
I mean, you could, but I think that would just confuse you. Don't you guys, when you have things like that, don't you combine all the positives, then all the negatives, and then subtract them? No?
I combine the negatives and stuff.
That's what I just said.
No, you said combine all the positives.
Well, if you had positives, like if you had multiple positives and multiple negatives, you wouldn't. Okay. Thank you. Okay, now I have 5 over 4i plus 1. Can I leave it like that? No, I need to multiply by the
Reciprocal. Oh wait, conjugate.
Conjugate.
I was gonna say reciprocal, but it's not. The reciprocal.
so 4i minus 1. So your numerator, you're going to get negative 5 plus 20i. Yes? Okay, do you see I'm just going right to standard form? Okay. In the denominator, you're going to get 16i squared minus 1. So that becomes a negative 16. So your denominator is negative 17. I shouldn't have put my signs in there, huh?
How'd you get negative 16?
Because it was 16i squared. So I squared's negative 1.
Wouldn't it just be 15?
No, it's negative 16 and negative 1. So then negative and those would be positive. So that's what I get. Okay, so now to do it the way I like to do it, just to show you so you can see it. I'll do it in a different color. Blue. Blue work. Okay, so I multiply this by I and this by 4 plus I. So I get I plus I squared over I squared. I'm going fast. Is that okay?
No, I'm not even on that one.
I like the other way better. Already.
Already.
That one just like makes sense.
Okay, so on this side you get 3, not 3, how about 12, right? 12 plus 3i over 16 minus I squared. Okay, so over here I get negative 1 plus I over negative 1. So I'm going to get rid of that negative and just switch the signs of everything. Can't I do that? Okay. And over here we have minus, and this is going to be plus 1, so it's 17. So you have 12 plus 3i over 17. So I'm going to multiply this by 17. So I get 17 minus 17i minus 12 minus 3i. So I get 5 for my real.
You mean plus 3i?
Yeah.
No, you have to, this is a quantity, you have to distribute it.
Oh, that is
Okay, you get 5 over 17 and negative 20 over 17.
Whoa.
To me, I feel like that was less work. It was less carrying around i's. That's why I like it.
I like it.
Because you get rid of the i's in the denominator immediately. Again, it's personal preference. Did we get the same answer both times? Yeah. To me, it's just less mess. If you like the first way better, do the first way. Got it? Okay. Like I said, there's usually more than one way to do a problem. If you guys don't like the way I did it, come to me personally and we'll find a way that you like. Okay? Okay, so solve the quadratic equation. Well, we would factor, yes? But the first one you cannot factor because it is not a minus, it is a what? Plus. So I can't say x plus 2, x minus 2, can I? Okay, so let's take a little bit different approach. Well, couldn't I do x squared equals negative 4? And then I take the what of both sides? Square root. And I can only do this because there's like 0x there, right? I can only do this because it's a 0x. So now I have x equals plus or minus, what's the square root of negative 4? 2i. Where'd the I come from?
Negative.
From it being negative, right? So that's the answer. If I put that back in a factor, so I went back this way, wouldn't that be x minus 2i times x plus 2i? So can I, with the skills I have, actually factor the sum of squares now? Just throw what on it?
I.
Just throw an I. So if I had 16x squared plus 25. You'd say, yay, I could factor that if it was a negative, right? But since a positive, we're going to do the same thing. Wouldn't it be 4x minus, oops, I have to put the I. Oh, that's fine. Never mind. Ignore me. 4x plus 5i. And 4x what? So my solution would be x equals plus or minus 5 fourths I.
Is 16x squared plus 25 a different problem?
Yeah.
Okay. I was really
There.
confused there for a second.
Sorry, I didn't
Okay.
put some squigglies. It was just another example. So we can actually factor the sum of squares. Do we get real answers? Are those real numbers? No, they're not real solutions. I can't graph them, but are they solutions? Yes. So that's the difference between knowing if it's a real solution or a non-real solution. Okay, so now I have 3x squared minus 2x plus 5. So that means the factors of 15 have to add to 2. Is that impossible? Yeah.
Oh, add to 2.
Yeah, add to 2. To add to 2 is impossible, correct? If I said subtract to 2, you'd be all good. Again, the subtraction makes a difference. So if I can't factor and I have all three terms, I have to use what wonderful thing there is? The quadratic formula. So what's that going to be?
Students going for manufacturing days, please report to the front door, the landing by the front door. That's all the students going to manufacturing day with Mrs. Tronick. Please report to the landing of the front door.
So x equals what? Fill it in.
X equals, wait. B
All over 2.
plus or minus the square.
So what is it? Like, just tell, I don't care about the formula. You guys should know it by now.
Yeah.
I don't remember
Negative
the beginning
2x.
part, but I remember what's under the square root.
Negative b plus or minus the
The
square
square
root of b squared minus 4ac all over
2A.
2a. Learn it.
Okay, so
I forgot the negative b.
Okay.
it's 2 plus or minus 4 minus 4 times A times C. Or times A
How about
plus
the
C.
square root? So 4. And then minus
Minus
4ac. So that would be 20 times 3 is
60.
60. All over
Wait, did you times that?
6.
Oh, wait, no.
6. 4 times 3 times.
Yeah, I got it. I figured it out.
Okay. Now, normally you'd stop and say no solution, right? There's no real solutions, but are there solutions?
Yes.
Okay. So this gives me, what, negative 54? Under there?
Yeah.
Okay. So I have 2 plus or minus. So 54. How can I?
54I.
Yeah,
Oh, 56. Yes, it is 56.
Say upside down on you.
7
I
and
just
8.
repeated.
Sam, you are correct.
7 and 8.
7 and 8.
8 is
Well, 8 is 4,
times 4.
right? And I didn't keep breaking it down because all I need is 4, correct? So what's the square root of 4? 2. So 2, you're left with what in there?
14.
14, and what do you have to throw at the end?
I.
An I. Do you see why I close my square roots now? When I have to do more math, you'll usually find me doing 2I square root of 14. But technically the I should be at the where?
Okay.
The back.
You write this down.
Okay, so we're not done yet. What can I reduce out of everything?
2.
A 2.
Should be
Not on the 14, correct? I said no. So we have to separate real from imaginary, right? So it's going to be 1/3 plus or minus the square root of 14 over 3 I. So again, are there real solutions that I can graph on a graph? Plot on a graph? No. But are there solutions?
Yes.
Do those answer some of your questions, Miss Emma, that you had yesterday?
Oh, I didn't even start that part.
Okay.
I was just on the square root.
Okay. So now we got that figured out.
I guess.
But what I'm saying about CalChat, Emma, with that, it would tell you how the computer is looking for you to put in the answer. Because CalChat isn't going to have the same numbers you have. Does that make sense? It would be like if you were given a math Excel to say, show me example, it would show you how they wanted you to input your answer. Because you had it right, except for that 4 from somewhere. But you had it right, you just weren't inputting the answer.
I just don't know how to
correctly.
multiply them. In the square root.
Oh, okay, we can do that real quick. Okay, everyone good on this? Olive, focus. Are you good on this?
Mm-hmm.
Okay, you were the last one writing. I was waiting for you.
Yeah, see that?
Okay, just a second. Okay, that's the last one. Okay, so what does this say? The square root of -2 to the 6th. Yes? Okay. Well, that would be like the square root of -2 times itself 6 times. So that would be an even number of square roots? Okay, or we'll think about it this way. Could I also write this as the square root of -2 squared to the 3rd?
Yeah.
Why can I write it like that?
Because it's the same thing.
Because it's exactly the same thing, right? 2 times 3 is 6. Well, and I know squared right off the bat, don't you? The square root of -2 squared is what?
4. 2.
But -2. Because when you square a square root, you get exactly what's inside, correct? So that gives me -2 cubed, which would give me -8.
Oh yeah.
So how would I multiply square root of 54 times the square root of 8?
It'd be 54 times 8.
Would it just be that?
Yeah, but I'll show you an easier way in a second. Okay, so now this cubed goes to what? Both, yes? So 2 cubed, only because there's parentheses. If there was not parentheses, it'd only be on the I. Parentheses matter. So 2 cubed is 8. So 8I cubed. Okay, do you remember what I cubed was from yesterday? No, but do you know what I squared is? So I cubed equals I squared times I, doesn't it? And I squared is -1 times I, so it's going to be -I.
Yeah.
Okay, can I leave an I in the denominator? So I have to multiply the numerator and the denominator by
Conjugate.
the conjugate. So I If you want to put negative I, you can. I mean, positive, it doesn't matter. Just put I. Got it? Do you guys just write it once?
No, I write it twice.
You write twice. Well, you write it twice. But do you understand what I mean when I write it once? No. Okay, so 1 times I is 1 I. And then it would be negative 8 times,
Negative.
well, it'd be I squared. I won't skip.
So it would just be 8.
So it'd just be 8. Now, standard form, I can't leave the I in the numerator. I have to pull it out to the
The book,
side.
the computer wanted it written as 1 over 8 plus 0I.
Well, no, not this one. This one has an I.
Yeah, the computer wanted it 1 and then over 8 plus 0I. That's how I put it in.
The only time you'd say plus 0I is if the answer came out to just 1/8. Then you would put plus 0I. Now, if this said write it as a complex number, this would be plus a 0 plus 1/8 I. Does that make sense, Emma?
See, so this one was 1 over 3I cubed. And
So 1 over 3I, both of them cubed?
yeah,
Okay. So that's 1 over 27 times negative I.
yeah.
Okay. So then I. So I over negative positive 27. So that would be 1 over 27I. But if they wanted it a complex number, you'd have to say plus a 0 plus 1 over 27I.
Oh. Okay. I'll do that. Let's see if that's right. Oh.
Was it?
Like that, I guess.
Okay.
Oh, never mind. It wasn't a fraction. It was just 5I.
Okay, but they wanted 0 plus.
Yeah.
Okay.
It was.
Because remember when they want it in
Because
the
I put
complex
it-
number, you have to put that 0 in.
Because I put -1 and then it yelled.
Yes. Okay, so you were asking how to multiply the square root of 54 times the square root of what? 8.
It was like,
That's okay. We'll just do those.
I don't know, let me. wait.
No, it's
Let
no.
me explain.
Actually, both of them were negative.
It was like
Negative 54.
-5 plus square root of -8. And then it was like plus
Plus
7 minus
minus
square root of
negative 54.
Okay, can you tell me again?
It's all weird.
Can you tell Alex, can you tell me?
Having that too.
Can you tell me again please what it was?
Negative 5 plus the square root of negative 8 plus 7 minus square root of negative 54.
And they were in parentheses.
It doesn't matter. Because when you're adding, the parentheses don't mean anything. It's a subtraction where you'd have to distribute the negative.
Oh.
Okay, so I'm assuming you got 2, yes? And then you like freaked out a little? Well, 5 and 7 would give you 2, yes?
Yeah.
Okay. So
And then I was like.
now you guys know that you can't add these because the radicand is not the same. What's under it? Right? You got 8 and 54, so you know you can't add that. So, okay. You only can add when these are the same.
Oh.
Okay, so we need to simplify those. So the square root of 8, we already said that was 4 and 2. So I would have plus 2I square root of 2. Where'd the I come from?
Would it be 2 square roots of 2i?
Yes, but when you're going to keep working with it, I put it there. But my final answer, yes, I will put it in the back. Okay, now 54. 54 we said was, what is 54? What times what?
56 is 7 and 8.
Okay, so
6 and 9.
6 and 9. Okay,
So it'd be
so negative 3I square root of 6. Okay, am I going to be able to combine those two?
no.
I put that in and counted it wrong.
Yeah, it wanted the I outside.
Right,
No, I did
yes,
that too. I did that wrong.
no, this is what it wants. Okay, so 2 is the real part, yes?
Mm-hmm.
Okay, So now you have plus parenthesis 2 square root of 2 minus 3 square root of 6 parenthesis I.
It wanted the I in front of the parentheses.
Well, it technically should be in the back.
Yeah.
Did you try it in the back and it said it was wrong?
I'll try it.
It was in the front.
I know there, but where should the I be if it's in standard form, guys?
Yeah, I'll put it in the back.
It should be in the back. But do you see what I did with that I? Did you have 2 I's
Oh,
before?
it counted it right.
Yeah,
But like for like the computer answer, it had to be
right.
in the front.
And it shouldn't be in the front. Okay, so how did I get from this step to this step?
Yeah, it did not let me put it in the back. I had to put it in front.
I put it in the back and it counted it right.
Unless I did something else wrong.
Okay, so look here.
Yeah, I did.
Okay. How did I get from these last steps, guys? What did I do?
You.
What did I I factored
out.
out the I. Because there's how many I's can be in my answer? 1. And you guys were leaving 2 I's in there, and that's why I was counting it wrong. Okay? So you were doing the square roots right. Great. That makes me feel good better. Any other questions?
No.
Okay.